Good afternoon to all. I welcome you all for this afternoon session. Now I request Mr. S. Yemaya Bharati to take over the session.
Okay. Hi guys. We meet again, and today's session we discussed in the today's morning session we discussed about natural language principles, uh, topics, where it all started, and where it is going right now. So, in the afternoon session, I thought I would have a uh, give you a abstract about how natural language processing as a domain is evolving, what is happening around, and how uh, how you should see natural language NLP as a domain instead of looking at it in a plain sight that it contains text and it's gonna you know we are going to use computers, we are going to use machine learning in order to train or in order to develop some intuition across text language. It's not that. There are so many things other than so many things so intuitively awesome happening around the NLP domain. I just want to give you a knack of what's happening over there. So I'm going to share my screen and then we'll look into it. So yes, this is what we have been looking at. We started it just to give a quick recap on what we seen so far. We generally had a conversation on what is NLP, what is the current process, where it all started. I suddenly shifted into uh, how language is important, what is language, and I took some time to talk about our own, that is not our, I can say my own native language. And we talked about the NLP pyramid, which is very important. And we talked about the tools, different kinds of tools that are used. We talked about the distance and we talked about the modeling. Modeling is this synapses, hypernym, hyponym, synonyms. Those are the modeling terminologies. And then we looked into spelling correction, how it works. And then we looked into semantics and parsing. Uh, so all these things we have seen. Also, we try to get our hands dirty on the coding side along with the theoretical session. Along with the theoretical session. So in the afternoon session, we are going to talk about two things mainly. One is, we are going to see about two things mainly. One is how the coding part, hands-on part is there, what we are doing, what is there, those kind of information. And the second one that we are going to see is what are all the new things that are happening around the same. And as I said in the morning, I also took some time to get you the collection of data sets that you need. Yesterday so many questions were about data sets. I think around 4 or 5 questions were about data sets, where to find the data. I'll give you a set of data sets websites from where you can download any sort of data. I can assure you that you'll never have a situation where you don't find the respective data that you're looking for, respective domain data that you're looking for, apart from these 10 sites that I'm giving you. Because it has a collection of about more than more than 10 to 1 10 to 1 billion of data points. Okay, 10 million to 1 billion of data points in it, so no worries about that. I also took some also have in mind to give you the idea about what I am working, where the industry is, what kind of space that NLP is occupying in those cases. So that is what we are going to see in this afternoon session. Okay, get ready. Yesterday we talked about RNN being used in That is a sequence to sequence model being used in language transition, correct? So there is an advanced concept called attention, right? Yesterday I just gave a gist about what is attention is. So attention is shaking out the part where I feel it's important, or where telling the model to see look into the part where it is important. Okay, so here let's see what's happening. We are looking at an encoder and a decoder architecture. So what is attention? Attention is nothing but we will encode whatever we are receiving as an input into a format, and then we'll provide a weight to it. So this is a French terminology for I am a student. So what we are trying to do is we are trying to convert this terminology into English. Yeah, we are trying to convert that terminology into English. Okay. So encoder is nothing but an RNN unit, RNN layer, or let's consider just an RNN cell that is going to perform a particular type of masking operation. It will mask each and every input. What do I mean by mask? It will convert text input into sequence data, that is numbers, numerics. It's going to do that. So after that, from the numerics, now the decoder, what it will do is it will try to find the perfect numerical match for the target language. Here the original originated language is French, and that language's words are converted into sequence, numerical sequence. Now since it's converted into sequence, we'll try to form we'll try to get the most similar sequence to the one that we are receiving in the decoder side. This is how we'll provide attention to the model. Okay. So the classic example would be, so he shoes étudiant. That's the French term. Okay. And for that French term, if you look at it, the input is containing 3 words, but the output we are expecting has should be 4 words. But the model is able to produce that. How? Because of the attention. We will always, if you remember correctly, yesterday when we talked about LSTMs and stuff, we actually talked about how we carry forward previous cell state information, previous hidden state information. Correct? Now, so here what will happen is the cell state information of both these two encoders will be carried forward, and then it will provide, for example, for the first decoder, it will form a it will form, for the first encoder we have single word, second encoder we have single word, and the third encoder we have a single word. We are passing this to the decoder. Now the first decoder will decide whether it should consist only one single term, it should represent the whole input into one single term or not. Once that decision is made, it will decide whether it should pass the information to the next decoder or not. If it decides to pass the information to next decoder, the next decoder will decide what word to take, and then it will also decide whether to create another decoder or not. Likewise, based on the previous state information, whether we are conveying a perfect information movement across decoders is based on attention. Okay, so in this decoder architecture, what is the purple color is a decoder and the green color is the encoder, and overall it's a sequence to sequence model. We have a sequential RNN model. We are not sure. Let's consider it a simple RNN, or let it be LSTM or anything. But essentially, what is happening is this. Okay. Any questions so far? I know it would be confusing. I try to keep it in layman's term as far as possible, but yeah, any questions, guys? If not, I'll continue. Okay, then. So this is a sequence to sequence model without any attention. Keep this in mind. This is a sequence to sequence model without any attention. We will see how a sequence to sequence model will perform with attention. So now what we are doing is, we are, instead of transferring just a hidden state information of the last encoder, we are also transferring hidden state information of all the encoders, so that the decoder can be attention based. Like it will consider the hidden state of the first encoder because of the attention it receives, and the second decoder will consider the hidden state of second encoder because of the attention. So now what happens with the third and fourth is, we have only three attention here, we have only three hidden state here, but we are going to need two more encoders here. I'm sorry, we are going to need two more encoders here. So how this is going to happen? This is going to happen because we will mask the sequence and send it to different layers of input. Okay, send it to different layers of attention, different layers of attention input. Then the attention decoder will be able to pass through, I mean, gather all this information, and it will be able to do the machine translation. Okay. Any questions? Okay. Okay. So bidirectional LSTM. Yesterday we talked about LSTMs, right? We talked about LSTMs, their architecture, and how I gave a graphical illustration about I gave a graphical illustration about how LSTM works and so far. Today we are going to talk about bidirectional LSTM. Bidirectional LSTM. Okay. So what is happening when you say there is an LSTM cell? So it consists of three gates: input gate, output gate, and the forget gate. It consists of three layers: hidden state layer, candidate cell state layer, and then the output layer. Yeah, try to remember or try to recall if possible. So yes, that's the LSTM's architecture. So what's gonna happen? If you remember, we had a small SRN cell, right? When I say I'm using 32 LSTM units, what I mean by 32 LSTM units is it's gonna unfold 32 times. It's gonna unfold like this 32 times over the time period. Okay, over the time period, it's gonna unfold like this 32 times. That's what I meant. In the coding itself, that's what it means. Okay, so now what is a bidirectional LSTM? If you look at the stuff here, that is the image which is given below. Yeah, so if you look at the architecture below, you will see that there is an LSTM cell which is A, and then there is an LSTM cell which is A dash attached to it. It will also receive the same input, but it will receive the hidden state of A dash minus 1. So now if we go to this LSTM cell, that is the LSTM cell of X input X1, then the LSTM cell A will receive the hidden state information of A minus 1, correct? It will be in the forward direction. Here it will be in the backward direction, but the output is predicted, or the output is made. Okay, the output is made from both the forward and backward direction LSTM cell. That is why this is called bidirectional LSTM. While going through yesterday's lecture, I told you that there is an LSTM, bidirectional LSTM. There is attention networks. There is transformers. There is BERT models like that, right? So that is where natural language processing is at now. They use transformers, they use attention architecture, they use much more complicated networks like Siamese networks. Siamese networks actually is a close resemblance to bidirectional LSTM. Okay, instead of forward direction and backward direction, Siamese network will always continue to forward direction. Okay. So let's get into the use case of bidirectional LSTM. So just concentrate on the first image, first GIF here. He said teddy bears are on sale. Okay. In order to know that Teddy is not a person name, you should go back one step and go forward one step just to get a context of what the teddy here means is. So when you say bears next to teddy, then that means it's an object. And when you have a word like he said, then that means someone is referring to. Correct. You need to know these two information in order to decide whether Teddy is a person or Teddy is a name of a doll or Teddy is a name of a dog or Teddy is not a person, it's an object, it's not even a living organism, it's an object. All these information you will be you will be able to get only if you provide the context through forward and backward. Okay. So let's consider the second example. He said Teddy Roosevelt was a great president. So now the Teddy here is a part of a person name. How do we decide between those? Again, you should go forward and backward towards the towards the sequence in order to decide whether that particular token is an object or a person or a flower or anything like that related to, right? Okay. Now, in order to get a more useful visual, we'll look at another another visualization, which is the below GIF. This one. So how forward RNN or LSTM or anything works is like this. Let's wait for it. Now, consider only the blue color. Okay, that is what a normal LSTM cell will look like. We'll have an input, we'll process the data, we'll provide an output, we'll also provide the state information to the next input. Now, how a bidirectional LSTM works is like this. We'll pass the same input to two different cells. We'll carry the information from one cell to another, and we'll also carry the information in the reverse direction from one cell to another for the next cell. Okay. So in theory, these are all seems to be very tough, but when it comes to coding, it will be very easy. Like you just need some 10 to 12 lines of code in order to implement a bidirectional LSTM. It's that easy. So please ask any questions if you have any doubts if you have on this topics, because coding is literally easy. What's the difficult point is understanding the equation, understanding the idea behind why it been invented or something, why it's been invented or something, and in those zones. So yeah, just ask me any questions if you have. I'll be happy to answer. If not, we'll move back to we'll move forward to the next topic. Okay, so cool. We'll go to the coding session now. So we have seen about the distance measure, spelling correction, and parsing in one notebook. The next thing that we are going to do is we'll try to predict. Okay, I'll increase the font format once. Just a second. So it's visible, right? Is it visible clearly? Anyone in the chat box or? Okay, cool. Then I will continue. Okay, so again, what we are trying to do is we are going to import a data set. This data set is part of an hackathon. It's still active in the Machine Hacks website. So if you are interested in participating in hackathons and such, please feel free to use this notebook and make a submission. Uh, yeah, and it's also a prize-based hackathon, I guess. So yeah, let's see. So we are going to try predict the news category. Okay, that's the overall idea of the problem. We are importing this NumPy and Pandas as our primary and most essential, packages for any data science problem. And then we are reading. So they usually hackathons will provide the data format in CSV, but this guy's has given it in Excel. So in order to read it, what I'm saying is Pandas has a read Excel attribute. So read Excel attribute, and then it has I have to pass the file name, and then I say engine equal to OpenPyXL. OpenPyXL is a Python package which is required to do any operations on Excel. Okay. In the morning, I gave you one quick tip on how to know the parameters which you have to pass for a function, right? So but that function unfortunately had only two examples. Let's see this. So I'm clicking shift tab on this. So for the function read Excel, it has these many parameters. Sorry, it has these many parameters. I'm trying to copy it, but yeah, I did it. Okay, look at it. It has these many parameters within itself. So you can say which are all the columns you want. You can say what are all the, this is the file name. You can say the sheet name that you want. You can say whether header is there or not. Header is what we call as a column name. So if you say NA filter, then it will drop all the NA values, that is the empty values. If you say manage duplicate columns, it will drop duplicate columns. So if you say parse date and if you give a column name, then that column will be treated as a date time object instead of a string or a number. That skip rows, if you remember, we used yesterday on the on the Canadian retail price data, we used skip rows and skip footer. If you remember, that is what we have here. Skip rows is what I've selected right now, and there is skip footer here. These are all integer values that you can give. Even the documentation is so good that if it is a boolean value, they will say boolean. If it is a numerical value that they are expecting, they will say numerical 0. And if they expect any other data format, then they will say none. So you can be made sure that if it is true, then this parameter accepts only true or false. If it is 0, then this parameter accepts only numbers, integers. If it is none, then you have to check for an example. So how to check for an example? That would be like, again, press shift tab and go in. You will see here the parameters. So if you come down, there will be a doc string. Okay, there will be a doc string which is supposed to let you know about what is the function is all about, and then there will be a parameters. So for all the parameters, there will be an explanation. What are they expecting out of the parameter? There will be an explanation. So for example, if there is a none, okay, if there is a none, then they will say whether we are expecting an array like object or default it's going to be none. So, and what is the array like object is a list. Keep it in mind that it's a list. Whenever they say array like object, it will be a list. So when they say list of column names to use, if file contains no header row, then you should explicitly pass the header equal to none. See, you don't have to worry about anything. They will provide you with all the information that you need for all the parameters. Just the parameters, they will provide this much big information. And if you are a little bit confused about the syntax, so and they also say about the returns, what it is going to return. So they will also say that. So if you're confused about the syntax, they will also provide with an example, like how to use this function, how to pass a parameter. They will let you know about all those things. Mostly examples should be very limited. They can't give an example for each and every parameter, but they will have all the necessary examples that most people use. So you don't have to worry about most of the part. Uh, I hope this is useful, in cases where you feel I don't know which are the parameters to pass, and if you feel like I'm not sure whether to use this package or not, don't worry, just go ahead, install the package, and try to see, try to play with the package and see what are all the examples that are there, what are all the parameters that are there. Try to see all those things. I think you'll get to know Python very well by doing that. So we are reading the train file and the test file. All these will be available in this. All the data and the notebook file will be available in this GitHub. So just in case anyone wasn't able to come to today's morning session, I'm putting the link again in the chat box here. So I have pasted the link there. Take your time, go through the GitHub page and see whether it's useful to you or not. Right. So now what we are trying to do is, I'm sorry, these are duplicates. I'll remove those. Yeah. Now what we are trying to do is we are trying to import NLTK. If you remember, this is what we have seen on. This is what we have seen on our tools. NLTK is the second most widely used tools, and as I said, the tools that I ordered, like that I explained, will also be in that order. SpaCy is the first, NLTK is the second most widely used tool for NLP. So we are going to use NLTK instead of spaCy. And NLTK as a package, it doesn't come, it comes lightweighted. So you have to download what are all the stuff you need. I'll also show you how to download NLTK. So you can, if you need stopwords, if you need WordNet, you can just say NLTK.download of stopwords and WordNet. So again, if you're confused, just press Shift Tab. You will be able to, get the parameters, get the function, get the things that are in place. Okay, so since I already have it, it says package stopwords, it's already up to date, and package WordNet is already up to date. I'll also let you know about how to download everything from NLTK. We'll see about that. Now we'll see. Oh my God, what happened? Yeah, now we'll see what is the shape of the data. The shape of the data is, it has 7,600 rows and 2 columns. So the data looks like this. It has a story and it has a section. Our job is to classify this story into one of the sections, right? And we'll also see the test data shape. It has 2,700 rows and 1 column, which is the story, for which we are supposed to generate the section. But since it's an hackathon data, hackathons works like this. They will provide you with a training data set. So you can use the training data set to train your model, and they provide you with a testing set for which you have to use the model to predict the outcome for the test set that they have provided. So that is why it's like this, right? So now what we will do is, we'll check if there are any duplicates in the data. There is a function called drop duplicates in pandas to drop all the duplicates. As I explained yesterday, pandas always returns a new data frame. In case you want to do, you know, manipulations on the own data, own data frame, you have to pass in place equal to true. That's what you have to do. And all punctuations, what I'm trying to do is, news articles has so many punctuations and stuff in it. There we need to clean the data. So what I'm trying to do is, in order to get all the special characters which is there, which is there in the English dictionary, what I'm trying to do is string dot punctuation. It will return a variable, or it will return an character. This is a string. Okay, this is a string. It's of if you look at the type of this no, if you look at the type of this returned value, it's an str, it's a string. Okay, so what I'm trying to do is I'm trying to get a string iterable object. String is iterable in Python, so I'm trying to get an iterable object which will have uh, all the punctuations in it, which I can remove, or special characters in it, which I can remove. Right. So now we have all the punctuations in one place. Now what we'll do is we'll write a function punc remove raw text, and we'll say that we are going to from the raw text, if so okay, this format is called list comprehension. Okay, this format is called list comprehension. What we are doing in that is, for punc in raw text, if punctuation not in all punctuations, return punc. This is what actually we are doing. But the beauty of Python is it allows us to do all this in a single line. You can write like three for loops inside a single punctuation. You can write three for loops. You can write nested for loops. You can write nested if else condition inside a list comprehension alone. It will allow you to do that. That's actually great thing about Python. So I hope they have given you an introduction on these things in the sessions that came before today's session, because I think the schedule has basics of Python, if I remember correctly, or basics of data science, if I remember correctly. I'm not sure. So this is called list comprehension. I'm just giving a whole idea about how it works. So now, what is the join function? So as I said, string is an iterable. I'll give you an example by what I mean string is an iterable. Okay, let's say a equal to Himaya. So in C or any other high level language, if you declare a string, then it's going to be a single value. Okay, you can't split the string, like you can't pass through the string. But when in Python, if I say for I in A, print I, it's gonna iterate through each and every character in the string that I provided. See, so that is what we are doing here. I'm sorry, here. For we are actually accessing each and every character in raw text, and we are checking if that character is in all punctuations. Okay, what is this not in means? So Python is a low high level language, right? So if you say a equal to Himaya, and if I say I in Himaya, sorry, not in Himaya, I in A, it will say true, because it is able to find this I in the variable A. So it is saying true. Okay, that is what is happening here. What I'm saying is, I'm getting a string. I don't want that string to be in this all punctuations. I don't want that string to be in this all punctuation. So if I say I in all punctuation, it's gonna say me false. But if I say exclamation in all punctuation, it's gonna say me true because exclamation is present here. See? So essentially, this is what happening. We are trying to remove punctuation from our string and then again forming it as a string. Since we started to iterate through it, it will return each and every character. This join function will actually form the characters into a string, whole string. Okay. Now we'll see the stop words remover. So stop words dot stop words. The stop words is coming from NLTK. I'll tell you how it is. So we downloaded stopwords from NLTK and using that stopwords. So if I call the function stopwords.words and English, it will return me all the stopwords in the English. All the stopwords in English as a language. It will return me all the stopwords. Okay. So what we are trying to do is we are trying to remove the stop words. Stop words are the words which so if you carefully listen, I'll repeat some words over and over when I speak. That is because I that's my pattern, that's my overall imprint that I can talk on, right? So we don't want those kind of words in the news article. Since news articles are extremely well maintained and extremely well written, we don't want those kind of words affecting our prediction. So we are getting rid of stop words from our data. And then what we are trying to do is we are initializing a lemmatizer. So what is a lemmatizer? Let me show you how a lemmatizer works, and then we can discuss about what is a lemmatizer and why we need it. So we will take a look at this example. Lemmatizer.lemmatize of managers is going to be managers. But when I say managements, it is forming it to its root word. So essentially what this means is lemmatizer is supposed to work like a root word establisher. What it will do is it will try to find the root word for each and every word. Okay, so why we are doing this, in some places we'll have a word called manage, and in other places we'll have a word called manager, management, and in other places we'll have a word called managements. There is an S attached to it. Then the problem here is we'll consider all these words as a separate word, but that shouldn't be the case. All these words essentially mean the same. Since we are not able to process it properly, we are not able to separate it. So in order to do that, we are using this lemmatizer. Okay. And again, we are forming a function for called def of lem. We are going to return a word from the function, and we are going to lemmatize each and every word. Okay. Now, all together we'll form a new function called text cleaner, where we will call the stop word remover, in which we call a punctuation remover, and then we'll pass in the raw text data. Okay, while returning, we'll return the lemmatized data. So now what I done is train data dot clean story. Clean story is the one where the text strings are present. What I have done is train data of clean story equal to train data dot apply of text cleaner. So the data frame object has its own function called apply, which will apply so if you give any function to it, any function that you define in the code, if you give that function to it, it will apply that function for each and every record in the column. That is what this apply function means. So train data of story dot apply of text cleaner, what it means is it will pass. So I don't have to write a for loop. I don't have to write a for loop that will go through all the raw text data. I mean all the story, and then that will be given to each and every one of these functions that I have written. What I can do is I can directly call this apply function, which will do all those jobs for me, and it will also place the values in the particular order. Whatever order train.story is passing in, the 0th place, 1st place, first, I mean 0th index, first index, second index, whatever index value it has, with the same index, it will return the output of this function, text cleaner function, into this new column called clean story. We'll see how this goes. So it's running. If you see a star here, then it means the cell is running. It's taking time to run. So why it is taking time is because we have written four functions, and we are passing that four functions through 7,000 data points, around 7,500 data points, which is the original size of the train data. Okay. One important thing to notice here is when you write the same thing with a for loop, when you write the same thing with a for loop, it will take more time than it takes for the data frame apply function to apply all these functions together. Actually, it will take more time if you write a function. So whenever you are using something like, whenever you are doing something like this much big, not big, this much iterable components, whenever you are dealing with something like this, keep in mind, go with the already given functions already given, predefined set of functions, use cases, all those things. Don't try to do it on your own, which will actually be time consuming as well as time taking. So always go with the default functions, predefined functions, which will make your life easier. So we'll let it run. We'll see about the dictionary approach that we are taking and the train model, and then we'll see the multinomial database. Multinomial naive base uh, model, ML model. Okay. So sklearn is the primary machine learning library for Python. It has all the machine learning algorithms in it. So what we are doing is sklearn.featureextraction.text. We are importing count vectorizer. What we are doing in the count vectorizer is we are trying to get the count of each and every word across all the documents. Here, what I mean by document is each record in the data frame is a document for me. Look at the time it took, and look at the result. But the most painful was the huge reversal in is the text. So we got rid of the. So the best example would be if you look at here, the is a word which has been repeated for 2 times. So we don't want that word. It will be common across all the documents. We don't want that word to have any influence. So we remove that word, right? And we also removed all the punctuations in it. If you look at it, there is an apostrophe here which we got removed in here. There is no apostrophe after click on. Even on is not there because it's a stop word. Okay, now let's see about now let's take a look at the count vectorizer. What this will do is this will actually count the word, give a count for each and every word in the clean story. Okay, it will try to give each and every word a count. That's what it's going to do. We'll see how it performs. Just give me a sec. I'll run these individually just to have a cleaner code base. I have put everything down into a single cell, but it's usually better to run each and every individual line in each and every cell. That way you can go and debug if anything happens, if anything is not happening the way you wanted. So we have 35,000 words. We have 35,000 words across the clean story. For 7,000 records, we have 35,000 words. And so if you remember, yesterday we had this min-max scaler which we fit on the data. By fit, what I mean is we'll let this count vectorizer or that scaler will let him to take a look at the data, and he will have a generalized view on the data. Now what we are going to do is based on that view, transform the data in the way that I want, which is do your magic and get me a array. That is what we mean by transform and fit. Fit is nothing but get the sense of the data. This is what you are going to see. And if you see this again, give me an array instead of just taking a look at it. So let's see how this bow is. It's a NumPy sparse matrix. It is a NumPy sparse matrix. So whenever you face something like you are not able to access elements inside a sparse matrix, do this. You will be able to access the elements. Of course, if the element is too big, then it will not fit your screen. But just to get an idea of what is happening around, you can do this. So the first document, if I take the first document, If I take the first document, these are all the words that are there in first document. Okay. So if I say first document dot split of, so if I say first document dot split, it will split each and every word into a token. So now what I'm trying to do is I'm trying to show you people that. So look at the length of this. It's 14, right? Now let's take a look at now let's take a look at the length of this thing. Sorry, it is supposed to be a square bracket. I put a curly bracket. Oh, what happened? Oh, oh, okay, okay. I'm sorry. So when it is a matrix, you should say shape, not not length. If it is a matrix, you should say shape. So take a look at this. This has 35,000 unique values. Okay, 35,000 values, 35,000. I mean 35,000 records, and it has only 35,000 columns, and it has only one row. Right. So what is going to happen now is what I wanted to show is only the values that are there in the clean story of 1 will receive a value here. Other 35,000 will be 0. So we saw that train.clean story of 1 has 14 words. We can see that only 14 words, only 14 values are printed here. Why it is printing only 14 values? Because all the other values are 0. So print function is not printing it. So this is like a template vector. If you remember that hello example, right? That hello example, wherever h is there, we'll put 1, other places we'll put 0. Like that, wherever the word is found, we'll put 1, we'll put the count of the word, not 1. We'll put the count of the word. In other places, we'll put 0. Okay. So that is what I wanted to show you. This is how the count vectorizer is going to do its work. Now let's run it. So the TF-IDF, now what we are trying to do is, we are trying to get the TF-IDF value for the count vectorizer that we did. We formed an array of counts for each and every word. Now what we are trying to do is, based on that count, I am trying to get a TF-IDF array. Okay, as I said, today's session, in today's session, we are going to look at the concepts as well as the code. So this code is for the TF-IDF as well as the count vectorizer, both. So if we look at the story TF-IDF of 1, and if we try to print it, it's going to say sparse matrix. And now access it's going to say sparse matrix. Then I'm going to print it. Then it's going to give me 14 values. But if you look at here, this count, the count that we saw earlier from the from the count vectorizer has been converted into probabilities. Okay, has been converted into word probabilities. Look at this. So for this word to occur in this document, this is the probability. Right. Now what I'm trying to do is I have 75,000, I mean 7,500, 7,500 TF-IDF vectors. So if I say shape of TF-IDF, it's going to give me 7,500, yeah, 7,500 rows, 35,189 columns. 35,189 is the dimension of this matrix. Okay, it's the dimension of this matrix. Now, what we have done is we have done a feature engineering. That feature engineering has resulted in one column. This clean story as a one column has been converted into 35,000 columns. Okay, now we are doing the train test split, which we have already seen, and we are going to train the model for the X train and Y train. This is a multinomial naive Bayes model. This is just a model. We have to choose one model, so I chose a naive Bayesian model, and let's see that. Let's test the scores. So we are able to get 92% accuracy over the data, right? I'll also give you a hint, like if you take a look at the train data. So if you look at the train data, it has four classes: zeroth class, first class, second class, and third class. All the classes are mostly equally distributed. Okay, only the first class is 2700, which is 1000, around 800 data points above all the classes. But all the classes have at least 1000 samples. But in most cases, you will get a data which will have, you know, 50% or more than 70-80% in one class and just 1% in other class. In those cases, you will have to deal with the data differently. Okay. Another important update that I wanted to give is, if you don't want to do like so this is the train data, right? We have taken only the train data, correct? We have not seen the test data yet. So just to give an idea of how to do it, I'll give you a closer look. So we have performed like these many number of manipulations in the data, and we have performed a count vectorizer, we have performed a TF-IDF vectorizer, and then we have fitted a multinomial naive Bayesian model. These many steps we have done, right? There is an option to combine all these steps into a single process. That is the pipeline. You can pass the count vectorizer, you can pass the TF-IDF, you can pass the classifier. Okay, all this will be contained in the pipeline, and it will perform in the order that you are giving. This particular operation will be performed in the order that you are giving, and then you can just say train and Y train, it will fit, and then you can say predict test of clean story. This will make your life easier in cases where you are using more than one approach to get the data format. So yeah, any doubts so far? Any questions? So till now we have gone through how to do a classification, how to build a classification model, and this classification model has more than two classes. Since it's a multi-class classification, we have four classes, and the data is equally distributed. We've tried to use count vectorizer as well as TF-IDF vectorizer, and then we used a generative model, which is a multinomial based naive Bayes model, and we tried to predict where we got 92% accuracy. Uh, in the next part, we'll see about how it goes for sentiment analysis using tweets. We'll see about that, and we'll see the bidirectional LSTM. We'll see how convolutional neural networks can be used for text classification. We'll see about that, and then that would be the end of session. It's 3 o'clock now. We'll take a 10 minutes break, and we'll reconvene at 3:10.
Hey guys, just give me 2 more minutes. I'll be joining back. Just 2 more minutes.
Hi, hi guys. Sorry for the 3 minutes delay. So let's carry on with the session, or should we wait? Anyone? Okay, I think I'll carry on with the session. Before going in, as I said, before going for the break, as I said, uh, we are going to look at sentiment analysis, tweets on tweets. So the data has been gathered from this competition. So this is the competition. Uh, it's still running actually. In case if you are interested, you can try this competition, and the prize money is like $15,000. So yeah, I gathered the data from there. I also provided the data in the GitHub link here, which will also have the data. So no worries about it. Now, while running the code from previous, that is the predicting news categories, I said that I'll let you know how to download packages from NLTK. So this is how we do it. NLTK has a download option which will open a GUI for you. It's loading. Once it's, yeah, see, if you see here, it will open a GUI for you. If you click all packages, just double click on the all packages, it will start downloading. It's aborting my download because I have installed all the packages. If I go to all packages, all my packages have been installed. Take a look at here. All my packages have been installed. So I don't want any downloads. So it's restricting my downloads. Just in case, I'm telling you, just in case. So if you're using it from your Google Colab or your own machine, use this to download all the packages, because we will be using a wide range of packages from NLTK. If you take a look at it, we'll be using NLTK quite a lot in this approach. So I just wanted to show you how to do that. It's been done. Now let's import all the packages first. We'll look at what the package is going to do, how we are using it. We'll look at it in the on the flow. That is while we are going through, we'll take a look. So I am just importing the data using pandas, our favorite data frame tool. And then what I'm doing is looking at the data. So the competition is like this. They will give you a text ID, they will give you a text, and they will also give you a selected text. For this selected text, you should show what is the sentiment. So it's like if the given text is this, and there is a selected text out of this given parent text, what is the uh, sentiment? What is the sentiment in this? We'll try to classify that. We'll be provided these information, and then we'll try to classify that. So this is the this is how the data looks like. And let's look at the shape of the data, which is 27,481 data points. We have 20,000, so 27,481 data points. And let's look at the classes that we are going to classify. There are essentially three classes: neutral, negative, positive. Is there a positive sentiment in the tweet, negative sentiment, or a neutral sentiment? And we'll also try to look at the, I'm sorry, we'll also try to look at the number of data points each sentiment has. So pandas, if you guys are familiar with SQL, you will know that there is an option called group by in SQL. Similarly, as I said before, pandas is a SQL object for data frame, and it holds all the functionality from SQL. You can use anything. You just have to know the right functionality that you need to call. That's it. So train.groupby of sentiment. What is it? What this is trying to do is, there is a data frame called train, and there is a column called sentiment. I'm going to take unique on this column called sentiment. So if I take a unique, I'll get three values. I'll try to assign every other column in the data frame. Sentiment is one column which I've taken. Every other column is text ID, text, and selected text. I'll try to get the number count of all these three columns given the value is this in sentiment column. Do you understand? We'll try. The group by is doing this. Given sentiment column, it will try to get the count of all these three columns given the value in the sentiment column. It is trying to doing that. So negative has 7,781 text ID, 7,781 text, but the selected text is 5,861 because all other selected text will be empty. That's the idea behind it, right? So now we'll do a data cleaning. What we are trying to do is we'll take let's keep only two columns that we are going to use. One is the selected text column, another one is the sentiment column. Now let's see how our data looks like. This is how the data looks like. Now let's check whether there is a null value in the selected text. There is a null value, just one value. What we are going to do, we are going to fill that null value with no content, just some text. You can fill it with anything. I don't know. You can fill it with anything, but no content would be a bit more generic. So or a bit more colloquial for our data. So I'm using no content. Now, the next step about the data cleaning will be, these are the next steps. We are going to remove. Oh, I didn't share my screen, did I? I'm sorry. So yeah, I'm sorry. I didn't see that. I didn't share my screen. I just went on. At least you guys should have told. I didn't. You can't see my screen. So no issues. So there is this download option from NLTK. We'll go from the start. We are using this. We are getting this data from this Kaggle competition, which is currently running, and the prize money is like $15,000 or something. I got the data from here. I just thought that it would be, more interesting if I took a online competitions data and do classification on it, so that you will also get interested, or your interest will be piqued by knowing that it's there, and those things. We are going to use quite a bit of NLTK packages. So corpus we are using, stemmer we are using, tokenizer we are using. So in order to get all those, I'm going to download the NLTK tokenizer, NLTK package. So we have this. If you run nltk.download, if you run this GUI will come. This GUI will come. So using this GUI, you can just click on the all packages and then click download. It will download all the packages that you need from NLTK. Okay. So that is what it is. We are using a wide range of packages here, so I don't want to go into the package details. We'll go about we'll see these packages while we go through the code, and if we see any of the packages, I'll explain what it is doing there, those kind of stuff. We are using pandas to import. I'm sorry. Oh, again I clicked that. I'm sorry. Yeah, we are using pandas for importing, and then we are seeing at the head here we have text ID, text, selected text, and sentiment. As I was saying earlier, there is a text and there is a selected text. So the idea is to get the sentiment for the selected text given the parent text. Okay, that is the whole idea. Given the selected text, we have to get a sentiment out of it for a parent text. It also contains some things like this URLs. It will also contain this stars. It will also contain some, emojis, emoticons, all those stuff. We'll see the length of the data, which is 27,000. We'll see the unique values, that is neutral, negative, positive. We'll look at the group by, which I already explained. Given a column, what are all the values, or what are all the count of other column will the given column have? That is what group by does. And then we have data cleaning. What we are doing here is, we are starting data cleaning. What we are doing here is, we are only taking the selected columns, that is selected text and sentiment, and we are trying to see whether there is any non objects or null objects in this column. There is only one, and then I'm putting no content in that one. Okay, now the steps for data cleaning is this. We have to remove URL, we have to tokenize the text, we have to remove email IDs as well as emails, we have to remove new line characters, we have to remove distracting single quotes, all punctuation signs, lowercase, detokenize the text, and then convert a list of text to a NumPy array. This is what we are going to do. I tried to neatly organize this for you so that you can even submit this notebook as your solution in the code, solution in the Kaggle. And yeah. Yeah, dpure data is a function that I wrote, for which we'll use regex. This regex will actually identify each and every mail ID, each and every website link, https://www. That link will be identified. If you take a look at it here, docs.google.com, it has https://. So that is what we are essentially doing here. We are doing that. And then we are also substituting any kind of special characters from the data. We are removing the special characters and replacing it with no symbol. Okay, no value. And then we are replacing spaces which are more than one space. We are replacing it with single space. And then we are doing we are removing single quotes and then replacing it with nothing. So then we are calling this function called dpure.data, and we are running it. So what I am doing here is selected text is a list of, it's a data frame object. What I'm trying to do is I'm trying to convert it into a list, and then I'm trying to append, get the dpure, pass the dpure function for that selected data list, and then try to get the values. Okay, what happened? Expected string or white light object. Oh wait, I didn't run this. Yeah, so after passing it to dpure data, this is what our output is. Now let's tokenize the data. GenSim is a tool which we discussed in the today's morning session, didn't we? Sorry, I have to run it again. I'll run all this again, and then we'll go to the GenSim package. So if you remember, GenSim is a package. I try to, we already saw NLTK. Now we are using GenSim. I have also included Spacey in between. So we'll try to use all these things within a single file to, just to have a idea about what is happening. So now GenSim, if I pass a sentence and if I pass this parameter as DAC equal to true, it will actually remove all the punctuations. So in case I don't want you to get confused when you're viewing this code after a long time. So I gave comments on the way wherever I use something like what I'm doing in places. I have put comment on before, so you can always refer to it at any time just to make your life easy. So I'm passing the temp which I formed here into this send to words function. So if I pass it to there, this I would have responded if I were going, this text has been converted into a list of strings that have responded if we were going. See, it removed all the stop words, it removed all the punctuations. So if I take this son of a star, some star star star, so it will have only sun and off. If you look at it here, it has only sun and half off. Okay, so let's see how it runs. Oh, it's pretty fast. And then let's see the data format. Still we have 20,000, so 27,000, 27,481 data points. And then what we are trying to do is we are trying to detokenize. What this detokenize will do is we have tokenized the data. We have converted a sentence into a list of string. Now what we are trying to do is inverse the same thing. We are trying to convert a list of strings into a sentence. Okay, let's see how it goes. Take a look at it here. Have responded if we were going, if we are going. So sad. Bullying me. Leave me alone. Sons of. So we are trying to convert, we are trying to reverse the process, except we cleaned the data so well. We have cleaned the data so well. Okay. So now we'll try to convert it into an array. So now it's nothing but converting a list into an array. Okay. Now we are trying to give it as a categorical. Now the train.sentiment is having text value, which is neutral, positive, and negative. What we are trying to do is change the text value into categorical value. That is, we make it a number. That's it. So we are doing it like 0, 1, and 2. We are saying neutral is 0, positive is 1, negative is 1, positive is 2. Then we are giving it as a TensorFlow categorical variable. Okay. So if you look at the type of the labels, it's a NumPy array. TensorFlow will convert this variable into a NumPy array. Now what we are trying to do is we are trying to initialize, we are importing all the packages that we need from Keras. I think you'll remember Keras from yesterday's session. So Keras, this is the same tokenizer that we used in yesterday's session. Same pad sequences, same text-to sequences. All these are same from the RNN session that we had yesterday. So for each tweet, we are trying to have a sequences, padded sequences with converting each word into a number that is uniquely assigned to it, right? And then we'll have a label. Okay. Now what we are trying to do is we are trying to split our data into train and test set. So we had 27,000 data points. We have splitted the data into like 70, 70, 30, 20,000 in one train set and 6,000 in test set, right? So now it's the model building part. I have also given some description so that you can read on whenever you are visiting the code. And I've added this simple RNN code, right? If you don't remember from yesterday's session, we tried simple RNN also in yesterday. I just wanted to give an idea about how we can use simple RNN on a data like this. So I have made the code available. All you have to do is select the code, uncomment it, and then run it. It will run. It will produce a simple RNN model. Now let's see an LSTM model being trained on this. So here what I have done is I have initialized the sequential model, and I say the input layer is an embedding layer which will convert the sequence into an embedding, and then I'm saying LSTM is there. Now this LSTM has 15 cells. Now let me give an analogy on what I mean by 15 cells, because now we have it. So here when I say 15 cells, what it means is this particular LSTM cell is going to unfold like this 15 times. There is going to be 15 elements like this. This is one element, that is x0, x1, x2, up to, instead of xt and ht, it's going to be x15. Sorry, it's starting from x0. So it's going to be x15, x14 to h14. Okay. So now I have added a dense layer. Now previously we'll say the dense layer of 1 because we had only one output. Now we will say 3 because if you look at it here, the labels are a set of 3 values. The labels are a set of 3 values. 1, 0, 0, 0, 1, 1. So it's a 1 hot encoded label. So we are trying to say that dense layer is 3 and the activation is softmax. If I remember, so the softmax is nothing but it will give 0 or 1. So I trained model.compile will use the optimizer instead of Adam optimizer. I thought I'll use RMS prop optimizer. And then the loss is categorical cross entropy loss. We have 3 classes, more than two class. So we can't go for binary cross entropy. So I'm using categorical cross entropy. And the matrix is accuracy. And the checkpoint, we are saving the best model checkpoint just to load the model. I'm storing the model in the HD5 format, which is hierarchical file format, which is widely used across industry. So, and I'm calling the model.fit parameter, and then I'm calling the callback as checkpoint. If you remember callback, we used to have a callback that says patience equal to 1 or patience equal to 0. Here the period equal to 1. So we'll get that, and then we'll have, so the model has been trained on, and the loss is 0.82 and accuracy is 0.6. The model's accuracy is 0.6. Okay. Now, as I said earlier, implementing a bidirectional LSTM is a 4-line of code. So you have to say bidirectional layers.lstm, and then you have to say how many layers you want, right? So here also there is only 3 layers. One is an input layer, that is an embedding. Another one is a bidirectional layer, bidirectional LSTM layer, that is from the bidirections. And the next one is dense layer, that is the output layer. I'll also give you an analogy on how this will be. So now when I say bidirectional LSTM of 20, what will be happening is x0, y0, x1, y1, like this will have x20, right? We'll have till x20. Also, s of 0 will have till s of 19, and s dash of 0 to s dash of I will have s dash of 0 to s dash of 19. Okay, implementing is very easy. All you have to do is know the right parameters, and then just have the right intuition of when to use the correct model, when to use the correct thing, and those sort of things. That's what you need to do. But yeah, overall it will be like having an LSTM model which can go across the output and the input in order to learn itself, in order to learn from the best metrics that are possible. So I'll also run this model. If you take a look here, I'm calling epochs for one epoch. That is, I want the model to take a look at my data just once. So for this also, I have only one epoch. So when you are training, it is it's advisable that train for more than 100 or 200 epochs, so that you will get to know, or you will get to see your model generalizing. This is another approach that I wanted to introduce, that is using convolutional models. In traditionally convolutional models are used only in image data set. Correct? What we are trying to do is use the same for text data set. I think you have gone through convolutional neural models, so I'm not getting into the specifics of it. But what I'm trying to do is I'm trying to have a input layer which is an embedding, and then I'm trying to say I have a convolutional layer, pooling layer, again a convolutional layer, and then the maximum pooling layer, and then the output layer. So it has a four-layer structure CNN model, and also it is one-dimensional, 1D conventional, one conventional 1D model. There is also convolutional 2D model, which you have to replace this particular 1 by 2. That's it. Your model will turn from 1 to 2. But those kind of options are only available if those kinds of options are only advised if your need is that. But don't go for it until you have a need. So yesterday's session we discussed about how LSTM is so time consuming, so memory consuming and stuff. If you look at here, the single LSTM for a single epoch, it ran for 81 seconds. Again, the bidirectional LSTM ran for 104 seconds. No, it's obvious, right? When you run a single LSTM, it's supposed to be time consuming, and it's supposed to be memory requiring. And you run a bidirectional LSTM which has 2 layers of LSTM models on it, then it's supposed to go, then the time is supposed to go up, correct? So that is why it's going up. Take a look at the code files and go through it. I've added all the things that you need for the file to submit it into a Kaggle competition and stuff, in case you are interested, just to give you an opportunity on try different things, taste a hackathon, how it is, what is the timeline, what is the overall working procedure, and all those stuff. Hackathons are really interesting place to work when you are a data science or an analytics guy. Well, not necessarily, but even if you are an even if you are an uh, any other domain person, it's completely acceptable to go into hackathons and use your domain knowledge to solve particular problem across people, which will be uh, a very invigorating process. So we'll get into the slides now. What I have done in NLP is I've worked for an worked for a project on an health science related company where the drug trials are happening, right? I created an AI engine that will recommend the uh, uh, trial people and the trial users, drug trial users. I will try to suggest them with the proper parameters and stuff in order for them to uh, prove a drug test. That is what I did in health science. And then we created a question answering model using bidirectional LSTM. We given a paragraph. If you ask a question from that paragraph, the model will automatically generate an answer for you. It's like what a student can do. It's like what a fifth standard student can do. The model will do it for you. That much of intelligence are gone into that model. And Windows has this registry which holds all the software information that you have installed and everything. For a big infrastructure based company, we try to develop an approach where we solve this issue by updating Windows software with all the updates that it needs just by using an AI engine. And I have done a multi-label classification for an multi-label classification for a client where you have more than one labels for a data point. So if you say the tweets, then it is going to have one sentiment, neutral or either neutral or positive or negative. What happens if the tweet has a bias? Then you say it's going either positive or negative. For each tweet, let's say you have two values instead of one. How to do that? That comes under multi-label classification. I have done that. And yeah, classifying right now I'm working in the skilling platform. We are deeply into L&D, learning and development. We try to identify employees and we try to up their game by providing them with the content and recommending them the courses. And also we help organizations to train their employee better. So that is where I'm at. These are all the NLP related. Mostly I've done in NLP. Only the image and there are 2-3 projects that I did in image and one project that I did in audio signals that I didn't mention here since the session is on NLP and it's off the topic here, so I didn't mention. So this is me. And if you have any queries related to if you do any of these things in your time, and if you have any queries, please feel free to reach. And as I said, I would provide you with the datasets reference. I've collected this. I've collected this data. So these are the 9 sites in the world that you need to search for a data. Take a screenshot or take a note of it. So whoever asked about any data sets, you can go for this. Go and search in this data formats. I'm sure it will be available in this. Even after this, if you can't find it, let me know. I'll try to do. I'll try to. I'll try to help you as much as possible. So that's it. I wanted to have a 15 or at least 10 to 15 minutes Q&A session or question answering session in case anything is there. Oh, someone has asked, could you please share the code? I think I've shared the GitHub link before going for break, but anyway, I'll share it again. You can go to this GitHub, and then I've shared the GitHub link in chat box. You can go to this GitHub and sorry. You can go to this GitHub and take the code files, data files, everything you need out of it. Any other questions? Any more concerns? I would love to hear the feedback about this two-day session that I carried out, so that I can improve myself. Anything that I should include, anything that I missed out. Which classifier is most often used in NLP? Okay, it's not about the model, but anyway, the question is about classifier. I'll try to answer it. Based on the data set that I'm choosing, if I choose an binary classification data set, then I will go for logistic regression. Not me. In NLP, as a principle, if we find a binary classification data, the best model to go for is the logistic regression model, which is particularly invented for binary classification. Nowadays, mostly these updated models have come. AutoML is a concept that has been evolving around this industry, where you don't have to do anything. You pass the data. There is a complete architecture behind an software which will do all the stuff for you, and it will even produce a model that is the perfect result for the data that you give. That is called AutoML. Automatically, it will do ML models and all those stuff. It will do data engineering and all those stuff. There is a company called H2O.ai which works best for this AutoML. Okay. Sure. About the reinforcement learning question, I'll come next. Before that, Mr. Vijay Rajan has asked question about a classifier. So the classifier is, as I said, logistic regression is my first bet. If not, I'll go for any other classifying data set. But if you ask for one particular classifier, my best, or anyway the best classifier would be random forest classifier. So whenever you are trying something, just put the data into random forest classifier and see how it goes. If it doesn't work the way you wanted, then you can random forest will at least provide 70% accuracy for any data. If it doesn't provide, then you can say that this data is very much biased. It's not a model training data set. So I think that answers your question, Mr. Vijay Rajan. Ask me more, or continue this question if I didn't do justice to the question, if my answer didn't do justice to the question. So the next question is, can reinforcement learning be used for NLP or sentiment analysis? So reinforcement learning would be an overkill for sentiment analysis, because sentiment analysis is pretty straightforward task, where you have a data and you try to try to assign a label to it. But the core idea behind reinforcement learning is, it is difficult for one particular model to understand, so you assign a human based model where it will learn from all its mistakes. That is where reinforcement learning comes in. In sentiment analysis, you don't need something, or you don't need someone that has to learn from its mistake. So every model will, you can never have a model which is 100% accurate. If you get a model which is 100% accurate, then that data doesn't even need a model. If it is 100% accurate, you can write rules, just heuristics, to solve that problem. You don't need model. So in that way, if you want to solve sentiment analysis like 100%, or if you want to solve sentiment analysis by more than 99%, then you don't need a model for it. You just go for a rule based approach, or you go for a similarity based approach. Reinforcement learning will not be recommended over here. Oh, okay. Is Q-learning alone the available model for all reinforcement learning? The question is this: is Q-learning alone the available model for reinforcement learning? And it continues like 95% of the papers use the same. Okay, so the problem with that is, reinforcement learning started with DeepMind. There is a company called DeepMind. They started this concept of inventing the reinforcement learning models. But where it become Q learning is because of those Tesla guys, the OpenAI gym guys started Q learning. Because of them, they all started following because they have this huge community that can support. Because of that, Q learning become more popular. But yeah, there are much more reinforcement learning approaches that are available, but they are not being widely used. They are not being widely used because of people are like afraid of whether if I stuck in some question, there would be no one to answer for me or something like that. But when it comes to Q learning, there is a huge support around the community, and you'll get all your questions answered. So Q learning, if you want to continue in that space, then go for it. No issues. You can choose any reinforcement learning model that are available. Q learning is not the only alternative. There are. I think you can Google it. You'll get an answer for it. Yeah, sure, Miss Bhavatarani. Sure. Sorry. Sorry. Parvadavardhani. Sorry. So yeah, any other questions? Okay. Thank you. Can you share your contact details? Okay, sure. I'll send my email in the chat box. Feel free to contact. No issues. I'll try to revert back as soon as possible. Someone said the session were really wonderful. Thank you. Any more suggestions? Any more reviews on my session? It would be more than it would be very helpful going forward, whether I should take a session or not. So, was it good or bad? Anything? Feel free to.
I
Sorry.
request some of the participants to share your feedback or experience with the Maya Bharati. So,
Please feel free to say anything. Like if you say it's bad, I'd be happy to accept it because someone has to, notify or tell whether it's good or bad. Then only people will know. If it is not, then I would continue this blabbering blabbering session again and again. So if you say something, then I would update myself. Then it would be helpful for the next set of people. If it isn't helpful for you. Okay.
This is Vijay Rajan, sir.
Oh, hi.
Sir, good evening.
Good.
Last 2 days, you have been striving very hard to explain a lot of topics. You have been working for quite some time. Thank you for the wonderful session, sir. You gave a lot of, hands-on sessions with practical examples. Meanwhile, it was very interesting to hear certain things related to your own opinions and so on. Thank you for the wonderful time for the last 2 days. I hope we can have our seminars in future FDPs and workshops. Thank you, sir. Thank you so much.
Okay. Thank you so much, Vijay Rajan. Yeah, I hope it's the same feeling for everyone. If not, feel free to raise your voice. I think this is my last session. So yeah.
so there is no feedback from the remaining participants. So I, as a coordinator, on behalf of all the participants and on behalf of the organizing team, I take this opportunity to thank Mr. Imaya Bharati, Machine Learning Engineer, Heuristic Digital Technologies Channel, for accepting our invitation and for provided the 2 days. He spent the last 2 days with us and provided a depth knowledge in natural language processing and in recurrent neural networks with an excellent presentation and hands-on session with different use cases. Thank you, Imaya Bharati.
Thank you, ma'am. Thank you for this wonderful opportunity. You guys have been a wonderful crowd. I hope I hope that I at least delivered something that you can carry forward. And feel free to contact me at any time. I'll try to revert back as soon as possible. Any questions, any doubts, I'll try to clarify it. Yeah, my suggestion would be don't stop here. Once you learned, it's not about what you learned, it's about what you try. So go to the GitHub, it will always be open. Go to the GitHub, try those codes. Don't restrict yourself from trying. That's one point. Other than that, thank you so much for this wonderful opportunity. Thank you so much for listening, and thank you for your feedback. Some people had said very good session, and someone said thank you. And yeah, thank you so much. It's my pleasure.
Thank you. I convey my thanks to Imaya Bharati. I am also thankful to all the participants for their enthusiastic presence and participation. And then tomorrow's session starts at 10 a.m. in the topic of generative adversarial networks and in transfer learning. Thank you, one and all.
Okay. Thank you, guys. See you. Take care. Bye-bye.